Dear students, in the previous video we had a discussion over intermolecular forces and dispersion forces. In this video or in this session, we will discuss about the dipole induced dipole force and the special case of dipole forces. Myself Rama, SDMPU College, Panavar. In the last class, we had a discussion over intermolecular force. Intermolecular force is nothing but it's a force between the in two molecules. It may be attractive force or it may be a repulsive force. If the force is attractive, then the force is termed as van der Waals force. Van der Waals force is forces because it has three different types: dispersion force, dipole force, dipole induced dipole force. These three are the types of van der Waals forces, and this classification is completely based on the nature of the molecule. If it is a polar, then it shows dipole force. If it is a non-polar molecule, then it shows dispersion or London force. Correct? About all these things we had discussion in the last class. Dispersion force is force of attraction between the two non-polar molecules. Next is dipole force, force of attraction between the two polar molecule. Next is special case of dipole force. Okay, special case of dipole force is nothing but hydrogen bonding. Before that, what is chemical bonding or what is bonding? The chemical bonding is simply attachment of the molecule. Okay, just attachment or attraction is termed, or it may be converted into a bonding. The dipole force in the previous session we were discussing the dipole forces. In that cases, I using one word. Dipole force is the permanent force and it's the strongest force of attraction. Correct. And dispersion force is a temporary force. It's the weakest force of attraction. When force of attraction becomes stronger in case of a dipole, what is the reason of strongest force of attraction? It is because of the positive and negative charges. The molecule already has poles, negative and positive. The one positive charge of one molecule will attract the negative charge of the another molecule. This charge is strongly attracted. When charge is strongly attracted, what happens? It may be converted into a bonding. There is a possibility in case of a special case of dipole forces, or in case of the dipole forces. In a few molecule, or the molecule which contains or which has highest electronegative atom, then there is a possibility of formation of hydrogen bonding or stronger force of attraction. Okay, I am consider one example, hydrogen fluoride. Dear students, in between the hydrogen and fluorine, what type of force is there? In between these two atoms, fluoride and the hydrogen, there is a covalent bond. Okay, this is a force of attraction that converted into covalent bond. ಏನಾಗ್ತದೆ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಮತ್ತು ಫ್ಲೂರೈಡ್. ಸೊ ಇದು ಎರಡರ ನಡುವೆ ಏನಿದೆ, ಕೋವಲೆಂಟ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟೇಕ್ ಪ್ಲೇಸ್ that leads to formation of covalent bond. Here the fluorine is electronegative atom, therefore takes the shared pair of electron. Electron, one bond means two electron. These two shared pair of electron moves towards the fluoride, and fluoride become a partial negative, and fluoride has capacity of strongest attraction. So this is electronegativity. Still more electronegative atom. It attracts the shared pair of electron towards, and hence more negative charge is observed on the fluoride, and more positive charge is observed on the hydrogen. Okay. Next, another hydrogen fluoride molecule. Another hydrogen. Same thing happens in the another molecule also. Strongest positive charge, strongest negative charge, stronger positive charge, stronger negative charge. This is there. When these two molecules, such type of molecules, what type of molecules? Molecules contains more or strong electronegative atom. It contains fluoride. Fluoride is the strongest electronegative atom. So because of that, more charges observed, more negative charge, more positive charge. This negative and positive charge attract strongly when these two molecules come contact each other. When these two molecules come contact each other, fluoride and hydrogen strongly attracted, and this strong attractive force that leads to formation of new bond. There is a bond or generation of bond take place happen between the fluoride and the hydrogen. ಏನಾಗ್ತದೆ more electronegative fluoride ಇರೋದ್ರಿಂದ fluoride ಮತ್ತು hydrogen ನಡುವೆ stronger force of attraction ಆಗಿ so hydrogen bonding ಆಗ್ತದೆ. Okay, that leads to formation of hydrogen bonding. This is known as, or this is called as hydrogen bonding. Then what's the definition of hydrogen bond? What type of force is it? It is a force of attraction. Force of attraction between the fluoride and hydrogen is nothing but dipole force. It's a dipole molecules attract each other, and that leads to formation of dipole interaction or dipole force. This dipole force is become stronger, that leads to formation of a bonding. This bonding is called hydrogen bonding. What is the reason of using the hydrogen? Because the molecule contains hydrogen. Now, what is the hydrogen bonding? What is the meaning of hydrogen bonding? Clearly observe the nature and the type of bonding take place, and based on that we should give the definition. Okay, what is the definition of the hydrogen bonding? The bond between, please remember the very important thing. Okay, bond between hydrogen atom of one molecule and more electronegative atom of another molecule. There is no condition of fluoride only. It may be any other more electronegative atom also. Okay, fluoride is more electronegative. Okay, more electronegative atom and the hydrogen. When bonding take place, that bond is called as hydrogen bonding. Okay, not this one. This one is also bond between the hydrogen and fluoride. It is in the molecule, between the molecule. What we discussed things under this topic, we discussed about the molecular forces between the molecule, not between the atoms. Okay, so between the hydrogen and fluoride atom, there is a covalent bond. Between the one hydrogen fluoride and another hydrogen fluoride, there is a bond. The bond is called hydrogen bonding. Okay, just the force of attraction between the two molecules. Hydrogen fluoride strongly attracted because of their dipole nature. When the strong attractive take place, the two molecules get attached together, and it become a permanent one, and this one is called hydrogen bonding. The same thing observed in another two molecule in case of water. In case of water also, this is a water molecule, correct? The water molecule, in the water molecule and water molecule, another water molecule, the oxygen of one water molecule and hydrogen of another water molecule. Please remember that one. Hydrogen of one water molecule, oxygen of another water molecule shows some force of attraction. That force of attraction is type of dipole-dipole force, and this dipole-dipole force is very strong. This strongest force of attraction that leads to formation of new bond is called hydrogen bonding. Next, in case of ammonia, okay, hydrogen bonding is observed in case of ammonia also. In case of ammonia, NH3, okay, this is the structure of ammonia. So it can be represented in this manner also, hydrogen, hydrogen, hydrogen. So it is a tetrahedral structure, okay, tetrahedral geometry is observed. That part you have studied, will study in the chemical bonding topic. So this is the ammonia molecule NH3, and another ammonia, the nitrogen of one molecule and hydrogen of another molecule, nitrogen of one molecule and hydrogen of another molecule. Again it is a hydrogen bonding. Why? The reason is it is a hydrogen and that another molecule atom is nitrogen. Nitrogen is stronger or shows strong electronegativity. Because of that, this type of bond is called hydrogen bonding. What is the conclusion? Conclusion is hydrogen bonding is nothing but bond between the hydrogen atom of one molecule and the nitrogen, more electronegative atom of another molecule. So then, what are the more electronegative atoms? Now, fluorine is strong electronegative, next oxygen, next nitrogen. Okay, because of that, the molecule contains fluorine, oxygen, nitrogen, shows hydrogen bonding. So this is about the special case of dipole-dipole forces. Okay, how many molecule shows hydrogen bonding in under the dipole-dipole forces? Hydrogen fluoride, water, ammonia. Okay, 3 molecule showing this type of bonding or dipole-dipole force. So this is a special case of dipole-dipole force. Next, we move on to the dipole-induced dipole forces. What is the meaning of the dipole-induced dipole forces? Induced, induced by another. Okay, the meaning is there is no dipole or polarity. The polarity is induced because of the any other. ನೀವು ಓದೋದಿಲ್ಲ, ಇನ್ನೊಬ್ರು ಓದೋದನ್ನು ನೋಡ್ಕೊಂಡಾದ್ರೂ ಓದಲಿಕ್ಕೆ ನಿಮಗೆ ಮನಸ್ಸು ಬಂತು. ಸೊ ಇನ್ನೊಬ್ರು ನಿಮ್ಮನ್ನ ಏನು ಮಾಡಿದ್ರು, ಓದಲಿಕ್ಕೆ ಪ್ರೇರೇಪಣೆ ಮಾಡಿದ್ರು. ಸರಿ. ಸೊ ಇಂಡ್ಯೂಸ್ಡ್ ಡೈಪೋಲ್ ಫೋರ್ಸಸ್. ಆರ್ ನೀವು ಸ್ಪೋರ್ಟ್ಸ್ ಆ್ಯಕ್ಟಿವಿಟಿಯಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡಿಲ್ಲ, ಸೊ ಯಾರ್ದೋ ಒಬ್ಬರದ್ದು ಸ್ಪೋರ್ಟ್ಸ್ ಆ್ಯಕ್ಟಿವಿಟಿ ನೋಡಿ ನಾನು ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ಬೋದು ಅನ್ನೋದನ್ನು ನೀವು ತಿಳ್ಕೊಂಡು ಅಥವಾ ಆ ಪ್ರೇರೇಪಣೆ ಏನಾಗ್ತದೆ, ಸೊ ದಟ್ ಈಸ್ ಇಂಡ್ಯೂಸ್ಡ್. ಆ ಥರ ಇದಕ್ಕೆ ಇಂಡ್ಯೂಸ್ಡ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಡೈಪೋಲ್ ಇಲ್ಲ, ಸೊ ಇನ್ನೊಂದು ಡೈಪೋಲನ್ನು ನೋಡಿಕೊಂಡು ತಾನು ಡೈಪೋಲನ್ನು ತೋರಿಸ್ತದೆ, ಪೊಲಾರಿಟಿಯನ್ನು ತೋರಿಸ್ತದೆ. ಓಕೆ, ಅನದರ್ ಪೋಲಾರ್ ಮೊಲಿಕ್ಯೂಲ್ causes the polarity in the another non-polar molecule. That is called induced dipole. ಅಂದರೆ polarity-ಯನ್ನು ಇಂಡ್ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ. ಓಕೆ, ಸೊ in this case the force of attraction, it is a force of attraction between one polar molecule and one non-polar molecule. Okay, one polar molecule and another non-polar molecule. Better to use another also. Okay, can use any one. Another non-polar molecule. One polar, another non-polar. Now I think you get the idea how the dipole and induced dipole forces or interaction is observed in the between the molecule. Okay, so here I am consider one molecule. It is a dipole, correct? It is a dipole molecule because of the polarity. Polarity is a dipole molecule. Another non-polar molecule. It has charge, but charges or magnitude of charges cancels each other. Because of that, it act like a non-polar or neutral. So it is a non-polar molecule. Between the polar and non-polar molecule, this polarity, this polar molecule or the negative charge when contact to this molecule, it attract the positive charge of this one. The resultant is what happened when this polar molecule come contact to the non-polar. It has charge. Inside the core there is a charge, positive and negative both. When negative charge come contact to this molecule, it the positive charge moves toward the negative charge and negative charge moves away from the negative charge. So it is induced dipole. Happen induced dipole. This is dipole. Now force of attraction start. The force of attraction between positive and negative charge is nothing but dipole induced dipole. Okay. So then as a general example, so in case of methane, carbon tetrachloride, between the molecules of methane, carbon tetrachloride, we observe the dipole induced dipole forces. Okay. Now how to understand all the concept in generally. Suppose ನೀವು ಒಂದು ಬಸ್ನಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ದೀರಿ, ಓಕೆ, ಅವರು ಏನು ಸಾರ್ವಜನಿಕ ವ್ಯವಸ್ಥೆಯಲ್ಲಿರುವಂಥ ಯಾವುದೋ ವೆಹಿಕಲ್, ರೈಲ್ ಇರ್ಬೋದು, ಸೊ ಬಸ್ ಇರ್ಬೋದು, ಟೆಂಪೋ ಇರ್ಬೋದು. ಓಕೆ, ಸೊ ರೈಲ್ನಲ್ಲಿ ಟೆಂಪೋದಲ್ಲಿ ಅಥವಾ ಬಸ್ನಲ್ಲಿ ಹೋಗ್ತಾ ಇರುವಾಗ, ಓಕೆ, ನೀವು ಸೀಟಲ್ಲಿ ಕೂತ್ಕೊಳ್ತೀರಿ, ಒಂದು ಸೀಟಲ್ಲಿ ಕೂತ್ಕೊಳ್ತೀರಿ. ಸೊ ನಿಮ್ಮ ಪಕ್ಕದಲ್ಲಿ ಇನ್ನೊಬ್ಬರು ಬಂದು ಕೂತ್ಕೊಳ್ತಾರೆ. ಯು ಆರ್ ಎ ಒನ್ ಮಾಲಿಕ್ಯೂಲ್ and another person, stranger, is another molecule. ನಿಮ್ಮ ಪಕ್ಕದಲ್ಲಿ ಅವರು ಬಂದು ಕೂತ್ಕೊಳ್ತಾರೆ. ಸೊ ಅವರು, ನೀವು ನಿಮ್ಮ ನೇಚರ್, ಯುವರ್ ನೇಚರ್ ಈಸ್ ಟಾಕಿಂಗ್. ಓಕೆ, ನೀವು ಜಾಸ್ತಿ ಮಾತಾಡ್ತಾ ಇರೋರು. ಓಕೆ, ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್, ಮಾತಾಡ್ದಿಲ್ಲದೆ ಇರೋರು ಮಾತಾಡ್ತೀರಿ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಜಾಸ್ತಿ ಮಾತಾಡ್ತೀರಿ. ಸೊ ನಿಮ್ಮ ಪಕ್ಕದಲ್ಲೇ ಬಂದು ಕೂತ್ಕೊಂಡವರು ಸಿಕ್ಕಾಪಟ್ಟೆ ಮಾತಾಡೋರು. ಓಕೆ, ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್, ಸಪೋಸ್ ವಾಟ್ ಟೈಪ್ ಆಫ್ ಜರ್ನಿ ಯು ಆರ್ ಫೀಲ್, ನೀವು ಯಾವ ಥರ ಅದು ಫೀಲ್ ಆಗ್ತದೆ ನಿಮಗೆ? ಅಲ್ಲಿ ಒಂದು ನಿಮ್ಮ ಸ್ಟಾಪಿಂದ ಅವರಲ್ಲಿ ಸ್ಟಾಪಿಗೆ ಹೋಗೋ ತನಕ ಏನಾಗ್ತದೆ, ಇಬ್ಬರು ಮಾತಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಮಾತಾಡಿ ಎಷ್ಟು ಮಾತಾಡ್ಬೋದು, ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೋದು, ಇಬ್ಬರು ಕಾಂಟ್ಯಾಕ್ಟ್ ನಂಬರನ್ನು ಶೇರ್ ಮಾಡ್ಕೊಳ್ಬೋದು, ಆಮೇಲೂ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇಟ್ಕೊಳ್ಬೋದು, ಅಷ್ಟು ಮಾತಾಡ್ಬೋದು. ದೇರ್ ಇಸ್ ಎ ಪಾಸಿಬಿಲಿಟಿ, ಕರೆಕ್ಟ್? ಸೊ ಏನಾಗಿದೆ ಅಲ್ಲಿ, ಯು ಆರ್ ಎ ಮೊಲಿಕ್ಯೂಲ್, ಯುವರ್ ನೇಚರ್ ಇಸ್ ಟಾಕಿಂಗ್, ಯು ಆರ್ ಎ ಡೈಪೋಲ್. ಓಕೆ, ನೀವು ಡೈಪೋಲ್ ಆಗ್ತೀರಿ. ನಿಮ್ಮ ಪಕ್ಕದಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂಡಿರೋರು ಡೈಪೋಲ್, ಸೇಮ್ ನೇಚರ್. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದ್ಯಾಟ್ ಮಾತಾಡ್ಕೊಂಡು ಇಳಿದು ಹೋಗ್ಬೋದು, ಇಲ್ಲ ಮಾತಾಡಿ ಕಾಂಟ್ಯಾಕ್ಟ್ ಶೇರ್ ಮಾಡಿ ಬಾಂಡಿಂಗ್ ಆಗ್ಬೋದು. ಬಾಂಡಿಂಗ್ ಆದರೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್, ಮತ್ತು ಹಾಗೆ ಪರ್ಮನೆಂಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇಟ್ಕೊಬೋದು. ಓಕೆ, ಸೊ ಆ ಥರ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಪಾಸಿಬಿಲಿಟಿ, ಸ್ಪೆಷಲ್ ಕೇಸ್, ಕರೆಕ್ಟ್? ನಾಟ್ ಇನ್ ಆಲ್ ಕೇಸಸ್, in a few cases. Next, another possibility, ನೀವು ಮಾತಾಡೋದಿಲ್ಲ, ನಿಮ್ಮ ಸ್ಟ್ರೇಂಜರ್ ಪಕ್ಕದಲ್ಲಿ ಕೂತವರು ಮಾತಾಡೋದಿಲ್ಲ. ನಿಮ್ಮ ಸ್ಟಾಪಲ್ಲಿ ನೀವು ಹತ್ತಿದ್ರಿ, ಅವ್ರು ಹತ್ತಿದ್ರು, ಪಕ್ಕದಲ್ಲಿ ಕೂತ್ಕೊಂಡ್ರು, ಅವ್ರ ಸ್ಟಾಪಲ್ಲಿ ಅವ್ರು ಇಳಿದ್ರು, ನೀವು ಸ್ಟಾಪಲ್ಲಿ ನೀವು ಇಳಿದ್ರಿ. there is no force of attraction, just attachment. So it is a dispersion. You are non-polar molecule, the stranger is also non-polar molecule, there is no force of attraction, there is no sharing of anything. So dispersion forces, such type of force is dispersion. Next, what is dipole? Induced dipole is special. Okay, so ನೀವು ಮಾತಾಡ್ತೀರಿ, ನಿಮ್ಮ ಪಕ್ಕದಲ್ಲಿ ಕೂತ್ಕೊಂಡವರು ಸ್ಟ್ರೇಂಜರ್ ಮಾತಾಡೋದಿಲ್ಲ. ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್. ಸೊ ಏನಾಗ್ತದೆ, ನೀವೇನು ಮಾಡ್ತೀರಿ, ಕರೆದು ಮತ್ತೆ ಮಾತಾಡಿಸಿ ಬೇಡ ಅಂದ್ರೆ ಅವರಿಗೆ, ಪಕ್ಕದಲ್ಲಿದ್ದವರಿಗೆ ಮಾತಾಡ್ಲಿಕ್ಕೆ ಮನಸ್ಸಿಲ್ಲ ಆದರೂ ನೀವು ಮತ್ತೆ ಮಾತಾಡಿಸ್ತೀರಿ. ನೀವು ಮಾತಾಡಿಸಿರೋದಕ್ಕಾಗಿ ಅವ್ರು ಮಾತಾಡ್ತಾರೆ. ಸೊ ಇಂಡ್ಯೂಸ್ಡ್ ಅಲ್ವಾ? ಸೊ dipole, induced dipole force. So another type. Again, it is not a permanent. Okay, it is not a permanent. ಅದು ಪರ್ಮನೆಂಟ್ ಆಗೋದಿಲ್ಲ. ಓಕೆ, ಬಾಂಡಿಂಗ್ ನಾಟ್ ಟೇಕ್ ಪ್ಲೇಸ್. Dispersion force is temporary. Dipole, induced dipole is temporary. Dipole force is permanent and stronger force of attraction is observed. Dispersion force is weakest van der Waals force. Okay, it's temporary. Now the reason of the hydrogen bonding in the ammonia and water. Okay, in case of ammonia and water, the gaseous molecule exists in the liquid state because of hydrogen bonding. Molecule attract ಆಗ್ತದೆ ಬಾಂಡ್ ಮಾಡ್ಕೊಳ್ತದೆ. ಸ್ಟ್ರಾಂಗರ್ ಬಾಂಡ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನಾಯ್ತು? Come contact each other, compact arrangement is observed. Molecules not randomly arranged. So because of that, gases get converted into liquid. Correct? So liquid state ಅಲ್ಲಿ ನಾವು observe ಮಾಡಬಹುದು. Liquid state of ammonia and water is reason of hydrogen bonding. Okay. So these are the different types of van der Waals forces. Now, question is arises. What is the reason now? Solid exists in the solid, liquid exists in the liquid, and gaseous molecule exists in the gaseous state. Is it only because of intermolecular forces? Intermolecular forces ಇರೋದ್ರಿಂದ molecules ನಡುವೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರೋದ್ರಿಂದ ಅದು ಸಾಲಿಡ್ ಆಗಿದೆ. ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಆದರೆ ಲಿಕ್ವಿಡ್ ಆಗಿದೆ. ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇಲ್ಲದಿದ್ರೆ ಗ್ಯಾಸ್ ಆಗಿದೆ. ಓನ್ಲಿ ರೀಸನ್? ನೋ ಅಲ್ವಾ? ಸೊ ಬೆಟರ್ ಎಕ್ಸಾಂಪಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ವಾಟರ್ exists in the liquid state in the range of 0 degree to 100 degree. But we consider temperature. Temperature is also play important role in the states of matter. Okay, any matter that exists in the state of solid, liquid, gases, it is because of one reason is intermolecular forces. If the force of attraction is stronger, the matter exists in solid state. If the force of attraction is very poor, then that type of matter exists in the gases. For example, all diatomic molecule, what we consider in the previous class, hydrogen, oxygen, chlorine. So these diatomic molecules show a very poor van der Waals force. Very poor van der Waals force means dispersion force. Because of the dispersion force, molecules far apart each other. This is the reason of gaseous state of the matter. Hydrogen gas, oxygen gas, nitrogen gas, chlorine gas. Next, like water and ammonia shows some force of attraction. Because of that, it exists in a liquid state. Okay. Next, is it only intermolecular force? No, temperature also played an important role. Therefore, for the study of the states of matter, we should know about the intermolecular force. What type of molecular force is there, and what is the relation with thermal energy. Okay. What is the relation between intermolecular forces and thermal energy? How thermal energy is interrelated to intermolecular force in case of the matter, and how it is the or how it determines the states of matter. Okay, you already all know, when temperature increases, what happens? In any case of a molecule, if we increase the temperature, molecules goes away far or ದೂರ ಹೋಗ್ತದೆ ಅಲ್ವಾ? ಟೆಂಪ್ರೇಚರನ್ನು ಕೊಡ್ತಾ ಇದ್ದೀರಿ ಮ್ಯಾಟರ್, ಎನಿ ಮ್ಯಾಟರ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಾಟರಿಗೆ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಏನಾಗ್ತದೆ? ವಾಟರ್ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟಲ್ಲಿ ಇರೋದು ಗೇಸಿಯಸ್ ಸ್ಟೇಟ್, ವೇಪರ್ ಸ್ಟೇಟಿಗೆ ಫಸ್ಟು ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. ರೀಸನ್ ಈಸ್ molecules, the force of attraction decreases between the water molecule H2O. When you supply the thermal energy, the molecular force of attraction decreases, hydrogen bonding breaks, and molecules become free and evaporated, goes to gaseous state. What is the conclusion? As the thermal energy increases, intermolecular force of attraction decreases. Due to that, the liquid state molecule goes to gaseous, solid goes to liquid. Conversion takes place. So therefore, thermal energy also played an important role to determine the states of matter. Okay, how these two are interrelated? thermal energy and intermolecular force. Thermal energy is inversely proportional. Inversely ವಿಲೋಮಾನುಪಾತ ಅಲ್ವಾ. ಸೊ ಕನ್ನಡ ಮೀಡಿಯಂದಲ್ಲಿ intermolecular force. As thermal energy increases, intermolecular force decreases. If the temperature decreases, intermolecular force of attraction increases, and gases come to liquid, liquid comes to solid. Okay, that is the role of thermal energy between the solid, liquid and gases. Okay, very easy thing, general thing. Okay, I think all of you are able to understand the concept of intermolecular forces and the thermal energy. Okay, in the next video we'll discuss about the gaseous state. Okay, their gases laws, gas laws, and other characteristic of gases and all that. I think you are again well lucky. Liquid state of this topic, or the liquid state of this states of matter is deducted from your syllabus. Okay, only gaseous states retained. Okay, thank you for watching.